Hello, my name is Chris Fitzpatrick, and welcome to my Physics 2212 Lab 3 presentation. The purpose of this lab was to understand the concepts of magnetic field and observable distance and their relationship, specifically for the magnetic field of a dipole on axis and superposition, to understand the Biot-Savart law, and to model magnetic fields using GlowScript. Here are the images that correspond to the procedure instructions. And I do not have enough time to say these out loud, so I'll just leave them on display for 5 seconds each. So, the instructions for measurement. Find a distance from the magnet to the sensor that produces a magnetic field with an x component of magnitude bx is equal to 20 microteslas. We will call this distance R20. Record this distance and this value of bx in the spreadsheet provided on campus. Repeat what you just did 2 more times. This way you will have 3 measurements of distance and bx at R20, and the spreadsheet will calculate their averages. Find a distance from the magnet to the sensor that produces a bx of 70 microteslas. This distance will be called R70. Make 3 measurements of distance and bx and record your data in the spreadsheet. Repeat the procedure for distances R120, R170, and R220, and record your data in the appropriate locations in the spreadsheet. And here's my data that I recorded. And here's my data analysis. B bar is equal to k times r to the nth power. And then this can be simplified by using the natural log on everything. So you've got the natural log of the magnitude of bx is equal to the natural log of k plus n times the natural log of r. N was then calculated to negative 3.2631 with an error of 8.1% because it's supposed to be to the negative, or n is meant to equal negative 3. Natural log of k is negative 14.887, and k is equal to e to the power of negative 14.887, and k is also equal to mu 0 over 4 pi times 2 times magnitude of mu, which means that the magnitude of mu is equal to k divided by mu 0 divided by 4 pi times 2. Here are the graphics for the off-axis measurement instructions. Once again, I will leave them up for 5 seconds each. And here is my GlowScript code, and you can see that I have mu over 4 pi. I've got calculations for magnet mu hat for k, the magnitude of mu, and everything that needs to be printed. I set the B scale to be 1000 and the distance to be 0.16 because I thought that was the best image result. I then set all the observation locations, and for our axis and our perp. And here's the remainder of it. And then got the average of D perp from my experiment, observation location at 45 degrees, and I have everything that concludes it. And at the end it says it prints all done, and this formula right here, B is equal to mu 0 over 4 pi times 1 over r cubed multiplied by 3 times the dot product of mu and r hat multiplied by r hat minus mu was very helpful in solving these. And here is my GlowScript graphic right here. And measured versus calculated. So the average measured is 1.793 times 10 to the negative 4th teslas, which you can see right here. And then the calculated is 1.512 times 10 to negative 5 teslas. And here are the what-if problems. What if you hadn't oriented your experiment to compensate for magnetic north and had instead laid out your meter stick at some intermediate angle with respect to Earth's magnetic field? How would your results have changed? The answers would be off due to the Earth's magnetic field, and the magnitudes would decrease. And what if you were to stick 2 identical magnets together end to end and run the experiment again? How would you expect your measurements to differ? The qualitative results should be the same, but the values should double. So it would be in the same direction, but increased by a magnitude of 2. Yeah, and that will be it. Thank you very much for watching. I hope this was informative, and if you want to replicate this, I hope you can. Bye.